What's up guys, Shawnthebro here. We're going to get started today on something that you guys have been asking a lot for. This time we're going to be working with left and right character movement. So left and right character movement, as I'm calling it, is basically your characters will always face each other. As in a lot of fighting games, you don't necessarily want to have the default rotation that Unreal has, where you see it, if I press left, my mutant character would actually turn and face the left direction. That's not exactly what you want in most fighting games. There are fighting games that support that. But I would highly recommend turning it off if you're going for the Street Fighter or Tekken style fighting game. So this is how we do this. I'll get right to it, jump into it because it's kind of a big one. Go to your side-scroller character blueprint class. This should be your template character class. Or go to your C++ fighter template character class, which is, again, your template character. And there's two ways you can do it. You can either go down to character movement, rotation settings, orient rotation to movement, and uncheck it, disable it. Or go into your code class and your constructor, get character movement, be orient rotation to movement, and set it to false. They don't matter, honestly, which way you do it. It might matter somehow if you derive off the blueprint and not the code class or some very specific case. But otherwise, I would just do one or the other. I did both for terms of the for the tutorial, but that's all you need there. And that'll basically mean you don't have to do that little rotation when you press left that'll make your character turn left. Instead, they'll just always be facing each other. Well, actually, right now, they'll always be facing one direction. We're going to make it happen where they always face each other. So there's a few things we need to do, and actually I can get rid of this. And I'm going to do them in default game mode BP. The reason I'm doing this is a server-only function, or the game mode is always server-only. So the reason I'm bringing this up already is because if you want to have networking in your game, we can still make this work no problem. In fact, I already have a plan for putting this in another file. But we will be moving this part in particular that we're going to do today, all this stuff right here, into a networking class when we switch to online multiplayer in this game. So I am well aware that the game mode is server only. I wanted to say it because some people had issues or concerns that this would not work with multiplayer. I have a plan, so don't worry. This can still work with local and online multiplayer. We'll just have to move out this specific function or these specific nodes, but I have a plan, so don't worry. I just wanted to point that out. To get back on track, so after we spawn the characters, we spawn the players. If you've been watching the fighter tutorial, you'll see that we spawn the players here, and we possess them here. And I don't possess player 2 because it's a long story, but if you've been watching this series, you know that there's issues because we don't have two inputs, and I don't want to control both of them and things like that. I also have a plan for this, don't worry. But after we do our spawn players function, I actually want to set player 1 and player 2 to have something called the other player. So the other player is a variable I made in the template character class right here. It's literally just a pointer to the class type itself, fighter template character, called other player. The reason for this is this variable will let you have a reference to the enemy player. You're going to need this because you need to know what side they're on to be able to flip and rotate and face them. We'll also use this down the road quite a bit. There's quite a few instances where you can use this and it'll be pretty helpful. So just make this variable. I definitely would encourage doing this in Blueprint where we set the other player to player 1 and player 2. You don't have to. The reason I do it that way is because since we're spawning the players from that blueprint, from the game mode BP, we want to make sure that the players are spawned before we try and set these pointers. Otherwise, they're going to have bad data or potentially data that's just not initialized. So make it here in your fighter template class. Go ahead and make an other player reference. And then in your game mode BP, or if you're doing it all code, again, you can do that. Just make sure after you spawn your players and after these would be valid, and I still check and make sure they're valid. Player 1 is valid, player 2 is valid. Make sure these are both true. Go ahead and set the players, okay? So player 1 sets the other player from player 2. Makes sense. Player 2 sets the other player from player 1. That makes sense. Because player 1's other player, or their enemy, is player 2. Player 2's enemy or other player is player 1. Now, this is something that we haven't dealt with yet, so I'll skip this for now, but just take note that there is one more node you should add in here. And this definitely doesn't have to be done here, but I also decided to do it in the game mode blueprint because this will be something that we do want to network when we know who's player 1 and player 2, who's server and client. So I kind of kept this here as a note to myself and to you guys. So we'll go over this today, but not just yet. Let's get into the code section because it's quite long. Okay, so it's not too big of a deal, but we do have to make some changes here. So, or not some changes really, but add some things. So first of all, and most importantly, we want a Boolean called isFlipped. This is how we'll determine, so by default, I'm assuming is player 1, which means player 1 is facing right by default. So if he is facing right, isFlipped is false by default, okay? If he's facing left, is false would be true. Or, excuse me, not is false. If he's facing left, is flipped would be true because he's not facing right, he's facing left. I know that's a bit confusing, but I think flipped is the best word here because we can actually use this in the ANA-BP and in the hitbox logic to make our game a lot smoother. And I'll show you how to do that in the next episode. So, most importantly, make this Boolean. It's also recommended that you would make a F transform and a F vector, one for one for the transform of the mesh and one for the scale of the mesh. You don't technically need these. You could leave them out. I made them because, again, I feel like there's going to be other use cases where I want to have the transform of the scale of the character. So I think that that's a good way to do it. However, you can absolutely leave out these variables, as you'll see in a second, and this will still work. But if you don't mind adding variables and don't mind the header file getting a bit bigger, then I'd go ahead and add these. Okay, now, as usual, in your constructor, just make sure you set everything properly. Other player, null pointer, since we're going to set it once we spawn it. And then isFlipped should be false by default. I didn't set these, F vector and F transform. I should, honestly. I was just kind of being lazy because it's midnight. It's 12:55 here, and I didn't feel like doing it. But I will definitely do it after this, or even right now. Here, we'll do it right now. Let's not be lazy. So let's do what's it called? Transform equals new F transform. Okay, and scale equals new F vector. So you'll have to initialize these, and it's probably saying because there's no, not new. Sorry, I'm working in the wrong language. I am legitimately working in the wrong language here. I could use new, but that does something different in C++. I apologize. So we're not going to do that. What we're going to do is initialize these to 0. And you can tell I'm a bit tired because I just did that in the wrong language. So anyway, and you can just make these. Basically, this just initializes a new F transform to all zeros, and this initializes it to all zeros for the scale. They probably should be 1. Who cares? This is going to be overwritten. Okay. The last thing we need to do in the code, and it's quite a big function, and listen, this is in tick. This is in tick. People are going to call me out on this, I know. There are better ways to do it. You could do it when, you could do it on an event, on a callback. You could do it on the movement. I get that. Tick is the easiest to get this done for now. And also, having functions and variables being set in tick is not as bad as people make it out to be. You don't want to put things in here for performance reasons, but for testing, for anything that's going to necessarily like quadruple your workload, not to do in tick, when you're just setting it up, put it in tick. Honestly, on the projects I've been on and the places I've worked, we've used tick quite a bit. We've never had performance issues. Just don't go and throw a lot of stuff in here. Keep it limited, but use it when you need it. It is there so you can use it when you need it. So tick makes sure that this function is called every single frame. So there are a lot of times when you will want it. But I just want to say that we can come up with a better solution. If anybody has an issue with it, there's plenty of different ways we could do it. That's where I'm going to leave it for now for the purposes of this video. But feel free to reach out to me as well if you just want a quick answer. Okay, so do super tick delta time. The super calls a parent function. So we're calling the parent class, which is a character, and we're calling their tick. That's important because you pretty much always want to do the parents class if you're not trying to change something that the parent class does. What I mean is we're not trying to remove anything that a character does, so there's no reason not to call super. If we wanted to not use functionality in a character, then we would not use it. Okay? So call super. And then here's where things are going to get a bit hairy, but this is the rest of the code for the episode. So we do if other player, which essentially checks if other player is null pointer or not. If other player is not null pointer, meaning they have spawned and we have set them to be player 2 and player 1, other player, if this part of the blueprint is already run, then we continue in the logic. So it'll make sure we don't crash at any point. We want to get our character movement, or this character's character movement. So character movement equals get character movement. And again, when you see auto in front of a variable name with an equals like this, you're actually assigning this if it's valid. So what it's doing is assigning character movement to this get character movement function. If this is not null pointer, then it says, okay, we're good, and we go into the if statement. Otherwise, it'll fail out of the if and go to the else if there's one that exists. Then we do the exact same thing, but we do it with enemy movement because we get the other player's character movement. And the reason I do this is because from the character movement, you can easily get the actor locations. You don't actually even have to do the get character movement, but I use it for other things. Like I plan on using it down the line, so I was trying to be proactive. So do however you see it fit, but if you set these to character movement, we can use it for stuff later. That's the easiest way to explain that. So enemy movement, if you get the actor location .y, because this would normally be your x-axis, right, left and right, but if you look at Unreal, it has this cool little axis thing in the corner. You can see by default that y is actually the x in this, and z is actually up and down, and then x is your depth. So x is your normal z is your normal y, and y is your normal x. If that didn't make sense to you, or you were taught using this orientation, then that's fine. If you're used to the regular x being horizontal, y being vertical, and z being like depth, then yeah, you'll see that a lot of times by default, the way Unreal makes their world is not how you would expect. So if you're using the template map and not one you made, y is probably your x value, and that's why we're using y. Okay? So basically, just check if your enemy is to the right of you or not. Okay? If you check if he's to the right of you, or check if he's to the left of you or not, you'll be able to determine if you should flip. It's as simple as that. If the middle of your enemy, and you can change it if you want it to be the edge of your enemy, like the right side of my enemy or the left side of my enemy. But I just did it. The get actor location gets the center of the actor. So if you're to the right or to the left, then we do logic, right? Okay. So what we do is if he's to the right of us, that means we are facing right because we want our character to face the right. Or we want our character to face the enemy. So if he's to the right of us, we want to be facing right. He should be facing left. So we check if he's flipped, and then we do some logic in here that's going to be a bit weird, and there's definitely a better way to do this. It's the same function, but without a hard-coded 1. Again, it's 1 a.m., so I will implement this for the next one, and you can change it then if you'd like, or you can reach out to me and I'll give you the quick answer. But for now, this is good. And as long as you don't change your actual characters like this right here, then this will work all the time. You don't have to worry about it, but I just want to point this out. I'm aware of this. So, okay, what we're doing here is we want to just flip the mesh. We could get the actor and change the actor's entire scale. If we decide to change the actor's entire scale, his top becomes bottom and his bottom becomes top. That means when you flip him on the y-axis, he will flip and he will be facing the right direction. However, he will no longer be able to jump if you switch sides with the enemy, because since you flip the y scale of the actor, the ground is being considered above you. You're going to be saying you always are in the air, which is incorrect. That comes down to the math that goes into all the scaling stuff. So don't worry about it too much. But what we have to do is actually get the capsule component, because the capsule component has the mesh. If you want to know why that is, I can show you that too. So when you go in, and this is something you can do, you can always use your world outliner while you're playing as well, okay? So if you scroll down, you can see I have mutant character BP. Now, in here, my scale for everything is 1. Now this mutant character BP is actually the guy on the right. You see it highlights it. He's actually the guy on the right. So his scale should not be, there we go. His scale should not be 1. If his scale was 1, he would be facing right? But if we go to the mesh, his scale is -1. The reason I explain that, I did not do this. This is what happens when you make a default character and use the template character and child off the template character. Like if this was side-scroller character or the mutant character BP, which is a child of the side-scroller character, then you get a setup like this. You have a capsule component which holds your mesh. We want to handle the mesh in this case. The mesh is the only thing we want to change. We don't want to change anything that has to do math or anything like that. And the only thing we want to change is the Y scale. So that's where this comes in. We get the capsule component. And I actually named this wrong. I just realized that. I called this capsule component. I should call this mesh. And I'm going to change it. I'm going to change it right now. Mesh. 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 There we go. And saying that, I broke my own rule. You should technically check if there is a capsule component before doing this. Because if there's no capsule component, you're going to crash. But I think you guys get the point of that by now by the 2 above it that we just did. Okay. So, we get the capsule component and get the child component of that. And with an index of 1. Your index just has to do with how it is set up in here. So index of 1 is the mesh. It's seriously that simple. So capsule component child is mesh. Okay? So literally what this is doing is grabbing the mesh. The reason I said we could do this better is you can actually find components based on their name, which is absolutely what you should do as opposed to doing this hard-coded 1. If you're working with other people who don't know what the point of this is, or if you plan on changing around your characters and adding components to them, you're not going to want to use a hard-coded 1. You want to always get the mesh. I will update that for next episode, but just be aware of that. If that's not working, it might not be grabbing the right value. But basically, once you get your mesh, it's just a series of math to scale it. So, okay, remember, if we are flipped, so if we're on the right, facing the left, facing our enemy that's on the left, and the enemy is on the left, facing us on the right, we get, okay, this is where our transform variable comes in. You don't really need to use this. I'd recommend it, but whatever. Just make sure you use your mesh and get relative transform. This will get you these values right here. It'll get you this box right here, this transform box, okay? Then we want to set the scale. Scale equals transform.get scale 3D. This gets you this specific part right here. And then what we care about is the Y value. So we do scale.y equals -1. We're literally just mirroring it. So we're not rotating him or anything weird like that. We're just going to multiply it by -1. And then we set the scale 3D of this transform to our scale that we just had x multiplied by -1, or x equal to -1. And then you use the mesh and set the relative transform to our new transform. So there you go. Once you do this, your character will properly flip. Make sure you set is flipped back to false, because we're going to need it if we ever want to flip him back to true again. Because in our else, if the enemy is to the left of us and not to the right of us, and we are not flipped, meaning we are facing the left, then we want to flip. So we do the exact same thing, but the scale is 1, not -1, and then set flip to true. Okay, so once you do that, you will be good to go. Make sure, there are a few notes I have here, and these are genuinely important. So make sure in your default game mode BP, or after these are spawned, you set player 2 to is flip by default. Tick will pick up on that, and it won't be a big deal. However, I would recommend flipping him by default. That way he's not facing the wrong direction to start. And you don't want to manually rotate him in the scene or anything. That's not very good unless it's just for a test level. So I would just go ahead and do that. Okay. Lastly, Make sure, so in this kit, in training level, make sure you have spawns, right? Earlier in this series, and this is why I'm bringing it up, I set the scale to -1 so that they would be facing each other. We don't want that anymore. If we have that, then these characters will be facing the same direction every time. We want them to be facing each other, not one at one's back and the other looking into the distance, okay? So make sure your scales are set to 1 and not -1 like we had done earlier in the series. Otherwise, again, this just won't look right. Okay? I think that's everything I got for today's episode, but that should help you. And by the way, you can use the mannequin. However, the mannequin by default is not set up. He's set up to be facing the camera. And since we have to flip the Y, he looks like this. Technically, he's actually working with the logic we have. He's not broken. So if you are using the template character, you can still get this to work. Just know if it looks like this, it's working. So basically, another thing you should know is if you use this tutorial, you will want your models to be facing, like your idle animation and your animations to be facing a way that this works, right? You will want your characters to look more like the mutant and not like because the mutant, you see his stance, he's facing right by default. This is what his default idle looks like. So when you flip him, well then he still looks good. So just make sure you have models that support that. Otherwise you just have to change up the way you do some of that scaling. Anyway guys, and I'll load this back up. Anyway guys, that is it for today. Thank you so much for sticking with me and for watching this video. If it helped you, please, please, please subscribe. It's the most important thing you can do to help me out. And I just really appreciate it. It lets me know that you're interested in this type of video. Okay, if you're interested in that, you might be interested in giving me more ideas to do for videos or having input, or if you have any questions or issues while doing this video, I recommend joining the Discord. You can comment down below and I will absolutely answer it. But if you join the Discord, I am able to assist you. I'm able to post pictures and videos to get back to you, which helps make it easier to, you know, actually solve things, but as opposed to just random text junk. So there's that. I'll post the Discord link in the description. It's always in the description. But if you want a different link, just reach out to me. I'll send it to you. Lastly, I just want to thank everybody who supported us on Twitch. We had a bunch of new people come from YouTube, say they were YouTube, that came and saw the Twitch stream of me playing Resident Evil 2. So thank you so much for coming by. Thanks for all the support you guys give. And if you want to support me, I'm Shawnthebro 27 on Twitch because someone stole my name. I don't know what that's about. But anyway, thank you guys so much. I'd appreciate any support. Let me know any questions you have. And I'll see you next week with the Super Smash Bros. Tutorial. Thanks everyone, I'm Shawnthebro, and I'll see you next time.